So,
where did you live before?
He's been living in Idaho.
okay, coming back out to y'all is, let's see, Carson. This is the quiz. If you watch the video, you can see it gone over. Finn as well as you. Watch the video, gone over it. And then coming out to you all is old homework from last time, so grab yours and pass on the rest, please. All right, what was the homework from last night? It was like 15, 16, 17 or something like that, right?
84.
Page 84?
No, 83.
83? 83, 84? Works for me. All right, let's go over them. See how we did. Okay, problem number 17 says this. Let the number of hours worked by Shannon be Y. Let X be the number of hours worked by Shannon, and Y be the number of hours worked by Jesse. Their sum of their hours worked is at least 50. So you have Shannon and Jesse. Shannon, we're doing X. Jesse, we're doing Y. Okay? So let X be the number of hours worked by Shannon, Y be the number of hours worked by Jesse. So it's X plus Y is less than, some of the hours worked is at least 50. At least 50, that means that they can work more than 50? I gotta flip that. I'm flipping that. Okay, so that's basically all we have to do on that problem, but let's talk real quick. What would the X-intercept mean in the context of this problem? And I'll show you on the graph, it's gonna look like this. You have 50 and 50. That's what the graph looks like. So what would the X-intercept mean right here? First off, that is the point 50, 0. Agreed? What does that mean? What does it mean? What does the problem say? What are Shannon and Jesse doing? They're working. So what would 50, 0 mean in the context of this problem? Yeah, that would mean that Shannon worked 50 hours. Okay? What about the Y-intercept in this problem, which is 0, 50? Who didn't? Well, somebody worked, but somebody didn't. Jesse worked 50 hours. So this means Jesse worked 50 hours. 50 hours. Okay? So a lot of times the X and the Y-intercept, if it's a word problem, has something to do with the context of the problem. Okay? Is that right? So that wasn't really part of the problem. Part of the problem is they wanted you to create this. All right, but we can talk about that. Let X be the cost of a large pizza and Y be the cost of a regular pizza. So problem number 18, a large pizza is X and a regular pizza is Y. 7 large and 5 regular pizzas were ordered, total $155. Ordered at a total of, okay? So 7x plus 5y, that's regular, were ordered at a total cost. So is a total cost, does that mean it's an inequality? No, it's equal. and it's equal to $155. Okay, so let's think about what this looks like on the XY axis. So we're going to figure out where it crosses the x-axis. So we have blank comma 0. So I'm going to make that a 0 right there. So 7 times what number? 7 times what number gives me 155? I don't know. Divide each side by 7. So x equals, is that 3? No, that's 2, sorry. 22. 1/7? Ew. 22 and 1/7 is like right here. So, okay, that didn't come out that nice. And then if I want to find where it crosses the y-intercept, I'm going to plug 0 in for the x. So that becomes 0. So that looks like 31. 0, 31. Okay? So what this means, this is an equality, meaning they told us that 5 of one type of pizza costs this much, 7 of another type of pizza cost something else. Did I say that right? It says, let x be the cost of a large pizza. Got it. Let y be the cost of regulars. 7 large and 5 regulars. So this 7 and 5, this doesn't represent how much the pizza cost. This represents that you ordered 7. So if you did some sort of combination of 7 and 5, you'd go 7 and 5. Somewhere in here would be some sort of price point. So what this means, if you were to order this context right here, 22 and a 7th, means that you could order 22 and 1/7 pizzas that would give you 155. If I ordered right here, what did that come out to? Is that 31? That means I could order 31 regular pizzas, and that would cost me $155. So that just gives you the combination of the two. And again, it's just what is the intersection of the x and the y axis mean in the context of the problem. Is that okay? Y is at most 9 less than twice the value of x. Ew. Okay, so number 19. Let's see number 19. Y is at most 9 less than twice the value of x. 2x minus 9. 9 less than twice the value of x. Y is at most. So this is equal, but it's at most. It's going to be that sign. Okay? This one, that's just, we have it set up. That's all we have to do. Write the appropriate equation of the inequality for each situation. And then 20, that's kind of a goofy one that they put in place. You won't see one like that on the test. And then 20, y is the cost of a plane ticket, x is the cost of one night at a hotel. The cost of a plane ticket is 80 more than and then 3 times the cost of one night at a hotel. And I'm just going to say we are going to skip number 20 because, again, I will not put that one on test. I don't have it. Look in the back. So, all right. I want us to take a quick glance at page 85. So if you have your book, have page 85 out. I'll put you in the book. Just put a 4 at the top. Okay, so page 85. So, number 1 through 4, the directions say this. Determine whether the relation is a function. Okay? Function meant what? What does a function mean? Yeah.
Well, if the
Yeah.
If the same number is not being used as.
Close, yeah. Yeah.
That's how it constant rate.
Okay. Yeah. Domain, which is the x value, doesn't repeat. Okay. So determine whether the relation is a function. If the relation is a function, determine whether it is linear or nonlinear. Linear means it would form a straight line. So looking at problem number 1, you have 1, 3, 5, 3, and then you have 4, 2, 0, negative 2. So is problem number 1 a function or not? No, why not?
Because
The domain repeats. The 3 repeats on the x value. So you have the 1 and the 5 are fine, they don't repeat, but the 3 and the 3 repeat. So that is not, and then determine if the relation is a function. Well, that's not a function, so we're not even going to worry about it. Okay, what about problem number 2? You have y equals 3. This is a straight line. Is it horizontal, vertical, or diagonal? Horizontal. So it's like this, right? Is that a function when you graph that?
Yeah.
It is. And so this would also be linear, right? It forms a straight line. Problem number 3. How would I graph that? What's the method I keep pushing on you? Cover method. Cover method works for straight lines, agree? So this is linear. This is not x equals a number, so it's not a vertical line. So is it a function? It is, and it's linear. Number 1 is not linear because you had to repeat in the domain. So you had like dots all over the place, like boom, 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 boom. Okay, number 4. Linear or not? Nope, not linear. Is it a function? I think so. The graph of this would probably look something like this. So that's definitely a function. I'm not expecting you to know that graph though. So I'd say if you could tell me that number 4 is linear or not linear, I think you're fine. You've done that part up. All right, number 5. We have this parabola, and I'm not going to draw the xy axis in. Find the domain and range represented by the graph. Determine whether the domain is discrete or continuous. Okay, so can we determine if this is discrete, so it starts and stops, or continuous, goes forever? Continuous. So it's continuous. Okay. Now, domain. Can I go forever to the left and forever to the right and have a picture of a graph above and below me? So this is basically what's going on. So if I keep going this way, does the graph keep existing above me?
Yeah.
What about if I keep going this way? Does the graph keep existing above me?
Yeah.
Yeah.
So the domain goes from negative to positive infinity. The range, though, is the y component, is it not? Where does the y pick up? I will tell you the y goes to infinity. So we look at the y component. So at 0, it goes, so from right here on up, it's going to infinity.
Why would it be a square bracket?
Square bracket because it's kissing the graph at 0 and the y value of 0. Okay? Number 6, you should be able to tell me if that is discrete or continuous. What do you think for number 6? Discrete. Why? There's no line. It's not continuous. You have to pick your pencil up to get to each point. Does that make sense? And I know you're going to get the one kid, yeah, but I barely lift my pencil up. So that's discrete. And then I have the following points. I have -2, -1. Agree? I have 0, -2. I'm just trying to list the points. I have -1, 3. And I have, is that 3, 0? So what would the domain be? The domain are what values? -1 what? Right there? So just list them. They can be in numerical order or all jumbled up. It's your choice. Doesn't matter to me. So that's the domain. The range is then what? What value is the range?
-2 to +2.
So there.
So for discrete graphs, you would just
List the points and then you just list the x values for the domain, y values for the range. And again, you don't have to worry about it. So domain and range here and here can be in whatever order. They're not meant to turn back into I can find the points. Okay? All right. Evaluate the function when x equals -1, 0, 1, and 4. Oops, let's just change this. -1, 0, 4. So first one I had g at x equals 3x squared plus 1. I'm not going to do all these. I think you'd be able to handle this. So what should I do with the -1? Plug it in. What should I do with the 0? Plug it in. What should I do with the 4? And then if you did the math, you'd get that's 3 plus 1, which is 4. That's going to be 0 plus 1, so that's 1. It's 16 times 3, which is 48 plus 1, so that's 49. Right? Pretty sure you could do that with 8 and 9 with no problem. You will not see one on number 9 on the test, so you can scratch off number 9. Number 10 and 11, go ahead and cross off. You're not going to see those on the test. So now 12 through 14. Okay? So they want us to find the x and the y-intercepts. Okay. They want us to find the x and the y-intercepts. X and y-intercepts means we're using the cover method. So it's 0, comma, blank, blank, comma, 0. 0, comma, blank, blank, comma, 0. 0, comma, blank, blank, comma, 0. All right, so if I plug 0 in for x, that's 0. So 3 times what number gives me 6? 2. All right, I'm going to plug 0 in for y. That becomes 0. So 2 times what number gives me 6? 3. Which one is the x-intercept? So 0, 2. 0, 2 is up here. 3 zeros over here. Which one? Which one's the x-intercept? Yeah, that's my x-intercept right there. So that must be my y-intercept. So if I plug 0 in for x, I find the y-intercept. If I plug 0 in for y, I find the x-intercept. Okay, problem 13. That's an x value right here. So that becomes 0. So 5 times what number gives me -30? -6. What about this one? That is a y value. -3 times what number gives me -30? 10. Again, x-intercept, or y-intercepts on top, and x-intercepts there. And then number 14, I can't really see what I have here. That's an x value. So I get y equals -8. Oh, that's already worked out for us. Nice. And then if I plug that in, I have 1/2 equals -8. So 1/2 of what? Half of what number gives me -8? 16. Right? (15) and 16. 15 and 16 are both done the exact same way. We have a table of values. We want you to find the slope. Okay? So here's where students start getting goofed up. Well, what numbers do I pick? Well, pick an x value and a y value. What do you mean? So, I think a lot of students look at tables and think it's a much more difficult endeavor than it really is. So you have negative 5, 7, negative 3, 4, negative 1, 1, and 1, negative 2. Come this test, you can pick either points that you want. So I'll pick those two. x1, y1, x2, y2. Slope equation's this. Change in the y over the change in the x. Okay, so y2 I said was 1 minus 7 over negative 1 minus 5. That's negative 6 over, down here is, that's plus, that's over 4. So you could leave it as negative 6 over 4, or you could reduce it to that, and that's your slope. Doesn't matter what 2 points you pick, as long as you don't pick the exact same point. Make sense? Number 16 is going to be done the exact same way. Okay? I think if you write the table as ordered pairs and then pick one ordered pair and another ordered pair, call that your x1, y1. Does it matter? No. They're all going to fall on a straight line. So do it how you like. Okay, 17, 18, and 19. So you have 5x plus 3y equals 15. You have y equals x minus 3, and then you have x equals negative 4. They want you to identify the slope, the y-intercept, the x-intercept of each linear equation. So 0 comma blank, blank comma 0 is how you find the x and y-intercept. Agreed? So this is a x value. 3 times what number gives me 15? 5. That's my y-intercept. How do I know it's my y? Because I don't go right or left in the 0 direction. I go up 5. The x-intercept would be the other one. Okay? So that's a y value right there. So that's going to be a 3. Okay, so I identified the, I need to find the slope now. In order to find the slope, you need your equation to look like this. So you need to solve for y. So if I'm going to solve for y, I'm going to subtract 5x from both sides. Is that okay so far? If I want y equals mx plus b and I have 3y, what do I have to do with the 3 to get y by itself? Divide everything by 3. Anyone want to take a shot at what the slope is?
Negative 5, 3.
Yeah, that's my slope right there. Alright, so this one, in order to find the x and the y-intercept on this one, it's a little different. It's not set up in the cover method fashion. But what value is this? Is this x or y? X. So if I plug that in here, what does y have to equal then? If I plug 0 right there, what is it y equal to?
Negative 3.
Negative 3. Alright, this is a y value, agreed? So that means 0 equals x minus 3. So what does x have to equal? How do I solve this for x?
3.
Yeah, add 3 to both sides. What is my slope? What is my slope of this equation? I'll tell you there's a 1 right there. What's my slope? 1. Done. What kind of line is this one other than straight? Horizontal, vertical? Someone has music on. How much? Is it vertical or horizontal? It's vertical. Okay. So let's just take a look at what this graph would look like. Someone still has music on. Where is this going to cross the y-axis? Someone still has music on. Where is this going to cross the y-axis? Where will this vertical line cross this vertical line?
It'll never.
It won't. Does not exist. Okay? Where will it cross the x-axis? Where's this? -4 comma what? There you go. What is my slope of a vertical line? Undefined. Good. Not 0. 0 is a horizontal line. Undefined is a 0 with a slash right through the top of it. It's undefined. Okay, remember, vertical and undefined. Vertical starts with a V. Undefined starts with a U. U and V are right next to each other in the alphabet. They go hand in hand. Okay? 20 and 21 you can cross off. You won't see on the test. 22 you will not see on the test. It should be on page 87. So if you have page 87, get that out. That's where we're at now. Okay. You all should be good with number 23. Number 23 is cover method. Agreed? Number 24 is slope intercept. So you plot the y-intercept, and then you use -2/3 as the slope to find another. 25 is cover method. 26, we can't see the whole thing, so just scratch that one. 27 I want to get to. 27 is the one that seems to give people the most trouble. So I have y plus 2 equals -3x minus 1. This is point slope. Okay, so what is my point going to be? It's always opposite ends here. 1
and
always opposite here. Done. There's my point. What is my slope? -3. So if you were to graph this, you'd be right there, and then from that you'd go down 3, right 1. That's all it is. So point slope is done that way every time. It's always opposite of your x, opposite of your y to get your point. Flip the page. Y equals 9. What kind of line? Straight. What kind of straight line? Horizontal. Horizontal has a slope of?
0.
Yes, 0. And then 29 and 30, we have it as an inequality. So we graph an inequality exactly like we graph a linear equation. But you have to watch out on an inequality that if you have a less than or greater than sign, it's dotted. So this is a dotted line. So where's the y-intercept on this one? 7. And then what's my slope? -1. So I'm going to go down 1, right 1. Solid or dotted?
Dotted.
Dotted. Okay. I'm going to use the point 0, 0 as my test point because my graph doesn't go through the origin. I did note on the test, 0, 0 will work every time. Cool? So I'm going to take 0, 0 and plug it in. Is 0 less than -0 plus 7? Is 0 less than 7? That's true. So I shade the side with 0, 0?
Yep.
I do. Done. So 29 was already set up in slope-intercept form, so use slope-intercept form. I will tell you, I think this would be a 5-point problem. Okay? So you would get, here would be your points. You shaded the correct side. You made it dotted. You graphed this appropriate. Yeah, I think it'd be 5 points. So graph it appropriate. So just by graphing it correctly, gets you 3 of the points. And then shading and make sure it's dotted or shaded, or dotted or solid, gets you your other 2 points. I think that's how I have it worked out. Number 30. Number 30 is not set up in slope-intercept form. This is set up as cover method, right? So 0, comma, blank, blank, comma, 0. That's an x value, agreed? That's an x value, agreed? So that's 0 now, right? So negative 2 times what number gives me 12? Negative 6. So 0, negative 6. This is a y value, so I'm going to cover this up. So 4 times x equals 12. So 4 times what number gives me 12? Solid or dotted?
Solid.
Solid. 0, 0 works as a test point. All right, so I get 4 times 0 minus 2 times 0 is greater than or equal to 12. 0 is greater than or equal to 12. True or false?
False.
That's false, so I'm going to shade the side that the 0, 0 is not on. All right, let me turn the lights on so you can see these a little bit better. Problem 31, you have a parabola. Okay, so I want to find the function at negative 3. So you have a parabola on that one. It looks like that, yes? So, the function at negative 3. So, I'm going to go from this value here straight up until I hit the graph. What does the function at negative 3 appear to be in the y direction? How much? 3? So the function at negative 3 would give me an answer of 3. This is 3f. It's a parabola. The domain goes forever left, right. So it's negative to positive infinity. The range, where does my range start? It does go to infinity. Where does it start? Negative 1, good. So look at your y component of your vertex, or the word turns, and it happens at negative 1. The interval of which it's negative, this is a little tougher. We talked about this a while ago. Where is it negative? Remember, a negative means that it would create a negative slope. So it's doing right here is where it's going to be negative. So talk about the story in the x direction. From negative infinity all the way up to negative 1 with a rounded bracket, our function's negative. Meaning if I were to pick any 2 points, it would have a negative slope to it as I get all the way to here. Okay? I don't include the negative 1 because at the very bottom that actually has a slope that's 0. Okay? The interval at which it is increasing. Oh, wait. Anyone see my mistake? This should actually be decreasing right here, not negative. And I'm not going to ask you where it's negative. If you wanted to know where it was negative, it's negative here. Underneath the X. That would be where it'd be negative, but I'm not going to ask you that. So just change that negative, make it decreasing underneath. And where is this bad boy increasing? So it goes from here to here. It goes from negative 1 to infinity. $32 is going to be done the exact same way. Exact same way. So the function at negative 3, it looks like it's at 1. The domain negative to positive infinity. The range goes from negative 2 to infinity. And then worry about just increasing or decreasing. Don't worry about where it's negative at this point. All right. That's all I got for you. Here is your take-home test. What's significant about the take-home test? Okay, for 25% of your test grade. Those of you who think I'm just going to pick some random arbitrary number out of the air and hope it's right, will get it wrong, unless you get real lucky. Of course, there might be that one student that says, well, I got a chance. Yeah, you do have a chance. Yep, this will be due tomorrow. You have the remainder of the period, which is about 10 minutes, to start working on it. That was just review. I was just doing that. I will put the points in for you. Put a 4 on the top of yours. Oh, do you have something to hand in? Does anybody else have old homework to hand in? Okay, so the take-home test. Thank you, dear. The take-home test. Problem 1, 2, and 3. One's asking if it's a function or a non-function. 2, 3, 4, 5, and 6 asks if it's function or not, linear or non-linear. Domain range. Find the functions at each. Thank you. 13, let's see. 11 and 12, you're finding the x and y intercepts. So 0, blank, blank, 0. Figure out which one's the x intercept, which one's the y. 13 through 18, you're just doing the slope. You're matching up the slope with A, B, C, D, E, F. 19 through 24, you're just graphing. Looks like 19's cover, 20 slope intercept, 21's cover, 22 is point slope, 23, it's x equals. So we've gone over that special case. 24 is y equals. We've gone over that special case. 25 and 26, one's cover, one's slope intercept, and you're shading, and you're doing solid or dotted. And then 27, I think you'd be able to go through. 27, look at letter C on 27. Notice there are 6 points. You have 8, 2, 3, 3, 2, 6, 5, 0, 5, 5, 0, 10. Agreed? Everyone still with me there? So what you're going to do is you need to figure out which one of those would work in my equation. My equation says 5x plus 2.5y is less than or equal to 25. So you take 8, 2, plug it in. Plug 8 in for x, 2 in for y. See if that is less than or equal to 25. If it's not a solution. You do the same with 3, 3, do the same with 2, 6, do the same with 5, 0, 5, 5, and 0, 10. Okay? This is due tomorrow. Remember, it's either right or wrong. There's not partial credit on it. So don't just put some random value hoping you get it. Yes,